In 1687, Isaac Newton's work, The Principia, was published containing his famous 3 laws of motion. 274 years later, the Vostok rocket is launched from Baikonur in modern-day Kazakhstan, and Russian cosmonaut Yuri Gagarin becomes the first man in space. This amazing feat of engineering would never have occurred without Newton's work on the science of motion. In this video, we will define motion and forces, present Newton's 3 laws of motion, and use Newton's law to solve basic motion problems. But what is motion and how does it occur? You recall when studying kinematics that motion, also known as velocity, is defined as a change in position over time. Newton's first law of motion states that an object will continue to stay at rest or remain in uniform motion, that is, its velocity is constant and in a straight line, as long as no net force acts upon it. What is force? A force is any push or pull an object might experience that has the potential to change its motion. The net force on an object is the sum of every individual force on that object. These forces are measured in newtons after Sir Isaac Newton himself. For an example of the first law in action, imagine a rocket shot into deep space with its engine turned off. In space, the rocket would experience very little force acting on it. We can approximate this net force as 0. The rocket, however, would continue to move at a constant velocity in a straight line even though no net force is being exerted on it. But what about the case where an object is exerted a net force on? This is Newton's second law, stating that an object experiencing a net force will accelerate in the direction of that force. It also states that this net force on the object will be equal to the mass of the object multiplied by the resultant acceleration of the object. An object's acceleration is the change in velocity over time. This can be thought of as a change in motion in an object's motion. Using this equation, we can calculate the force required to move objects with a known mass. Say we needed to know the net force needed to accelerate a 1,000 kilogram car 4 meters per second squared. By multiplying the mass of 1,000 kilograms by the acceleration of 4 meters per second squared, we calculate a net force required of 4,000 newtons. Another example. What is the net force required to bring a 1,500 kilogram car to rest from a speed of 100 kilometers per hour within 55 meters? In this case, we have information about the mass of the car, but we need to determine the acceleration. To do this, we can use the kinematic equations. The final velocity of the car will be equal to the initial velocity squared plus the difference in position times double the acceleration. Rearranging this, we can find the acceleration as the final velocity squared minus the initial velocity squared divided by 2 times the change in position. Now input the numbers and multiply by the mass, and we have our net force required to stop the car. Newton's third law states that whenever an object exerts a force on a second object, the second object exerts an equal force on the first object in the opposite direction. This can be seen in our rocket engine. The rocket engine pushes out gases downward. The gases in turn push up on the rocket. It is not the gas pushing on the ground, but the gas is pushing on the rocket that makes it propel upwards. Now, using your knowledge of kinematics and Newton's laws, answer the following questions. Pause the video and attempt them yourself. Did you get the answer? The acceleration was 20 meters per second squared, and the force was 780 newtons.